So friends, in this video, I will be explaining hydrogen spectral lines. So in this diagram, you can see that they have shown here on the right hand side n is equal to 1, n is equal to 2, 3, 4, 5, 6, 7. So these are energy levels or excited states. When n is equal to 1, it is called as ground state. In this state, electron or the atom is not in excited state. Okay. The atom or the electron will go into excited state only when it will absorb a photon, and depending upon how much energy it has absorbed, it can go to energy levels 2, 3, 4, 5, 6, 7. It can be 8, 9, 10, like that. So the atom goes into excited state after absorbing the energy because it needs the energy to go to higher energy levels. Otherwise, it can't go to that level or it can't go to the excited state. And a reverse is also possible. If the electron or the atom is in the excited state, when it comes from the higher energy level to the lower energy level, the photon is emitted, and that's how it comes from the excited state to the lower energy levels or ground state. Based upon the wavelength associated with the photon that is emitted or absorbed, various series have been created like Lyman, Balmer, paschen, bracket, and Pfund. So for the Lyman, the base state is energy level 1. What it means is that when the electron goes from the higher energy state to the energy level 1, that is called as a Lyman series. So here you can see that these three lines, 1, 2, 3, and the fourth line as well. So what it is indicating is that electron, let us say, is over here at level n is equal to 5. When that particular electron jumps to the energy level 1, that point of time, the photon will be emitted. And same way, it will happen for other three states as well. So that is called as Lyman series because all the electrons are jumping to the energy level 1 from the higher energy levels. For the Balmer series, you can see that the base state is energy level 2. What it means is that electron is coming from the higher energy states into the energy state whose value is 2. Then there is paschen with n is equal to 3, then with the bracket n is equal to 4, and Pfund n is equal to 5. So why they have created this series is because of the wavelength associated with the photon. For example, if you consider the Lyman series, we can see what is the wavelength for this Lyman series, 122, 94 in that particular range, right? In nanometer, this particular wavelength has been given in the nanometer. So whenever the electron is making transition in the Lyman series, the wavelength is between this range, 95 to 122 nanometer. And the color of the spectral line will be ultraviolet for the Lyman series. For the Balmer series, they have given these values over here. So you can see here the wavelength is increasing in this Balmer series. It ranges from 411 to 656 nanometer. And the spectrum is in the visible range with different colors like red, then green, and violet. If we talk about the paschen series, you can see that wavelength is increased further, 1282 to 1875, and it is emitting this infrared light. Here is another diagram which represents the Lyman series, Balmer series, and paschen series, and they have also given these wavelengths as well. So here they are saying that 122 nanometer is the wavelength of the photon when the electron comes from the energy level 2 to energy level 1. Then 103, 97, 95, and 94. That is for the Lyman series. For the Balmer series, what is happening is that electrons are moving from the higher energy state into energy level state 2, and their wavelengths are 656 nanometer to 410 nanometer in that range. And for the paschen series, you can see these are the wavelengths. Electrons are coming from the higher energy states to energy level 3. If you have more questions, let me know in the comments.